Assalamu alaikum everybody. We start our talk today. As I spoke before about the crude oil, and we said that there is two type of compound in crude oil. There is hydrocarbon compound and non-hydrocarbon compound. We spoke about hydrocarbon compound, and we said that there is three type of hydrocarbon compound: aliphatic, aromatic, and naphthenic. Aliphatic about 25%, which is saturated paraffin, started from C1 to C60 or more, either straight chain or iso chain, like this or like this. So it started from methane. Methane, there is no isomer. Ethane, methane, ethane, propane, butane, and so on. The first four compound is gases. Then from C5 to C17 is liquid. C18 plus it is solid or semi-solid. This compound is saturated and reactive, only substitution reaction and combustion reaction. Its octane number is very low for straight chain, and it is higher in iso chain. It is not desirable in benzene, the normal paraffin. Only isoparaffin is desirable, and kerosene is desirable. Diesel is desirable. It is non-polar, so it is not dissolved in water. So the aromatic about 70%. Aromatic is any compound which contains benzene ring C6H6, and it is unsaturated, and its high octane number. Its boiling point is more than paraffin because it started from C6. Maybe one ring or double ring or triple ring or more than that, but the existing in crude oil only aromatic with the three ring together with alkyl group or more. Its octane number is higher, and it is desirable in kerosene. Its viscosity is high, but viscosity index is very low, so it is not desirable in lubrication oil. Naphthenic compound also, which is cyclic, also saturated. Its octane number is high, desirable with gasoline. For olefin compound is not mentioned here because it is not existing in crude oil, but it is produced during crude oil processing or refining. So this is about hydrocarbon compound. So there is also non-hydrocarbon compound. Non-hydrocarbon compound like sulfur, nitrogen, oxygen, metallic. But this is not chemo-free. The sulfur not chemo-free, but nitrogen also, oxygen. It become as sulfur compound, as nitrogen compound, as oxygen compound, and metallic compound. So sulfur about till 8% weight percent. Nitrogen about less than 1%. Oxygen less than 3%. And metallic in ppm less than 100 ppm. So we come to the non-hydrocarbon compound. Also, these non-hydrocarbon compound, which mentioned now in the first page, also classified into a group: olefophobic impurities and oleophilic impurities. Oleophilic impurities, which is dislike oil, only like water. So it's including salt. Mainly chloride, this salt, either sodium chloride, potassium chloride, calcium chloride, and Mg chloride. In addition to sediments such as salt, sand, mud, iron oxide, iron sulfide, and water present insoluble emulsified and or finally dispersed water. Oleo impurities, here oleophilic impurities, are soluble or sulfur compound, organometallic compound, nickel, vanadium, iron, arsenic, naphthenic acid, and nitrogen compound. So the pretreatment of crude oil just only remove the oleophobic impurities, which is salt and water. We come to sulfur compound. Sulfur compound mainly present in the sour crude oil as sulfur compound, either monosulfide, disulfide, thiophene, H2S, طبعا crude oil during the process contain high H2S because all these sulfur compound is thermally unstable, so it produce H2S. So organosulfur compounds may be generally be classified as acidic and non-acidic. See, there is two types of sulfur compound, acidic and non-acidic. This is acidic. Mercaptan, methyl mercaptan, phenyl mercaptan, and cyclohexyl thiol. This is all acidic compound or acidic sulfur compound. And this is corrosive more than non-acidic sulfur compound. This is non-acidic sulfur compound will include monosulfide, CH3SCH3, dimethyl disulfide, dimethyl disulfide, also disulfide, and thiocyclohexane, thiophene, and benzothiophene. This is non-acidic. So sour crude contain high percentage of hydrogen sulfide because many organic sulfur compounds are not thermally stable. Hydrogen sulfide is often produced during crude processing. High sulfur crude are less desirable because treating the different refinery stream for acidic hydrogen sulfide increases production cost, because all this sulfur must be removed because it is corrosive and it is toxic. So we have to treat it by hydrogen. Most sulfur compound can be removed from petroleum stream through hydrotreatment process, where hydrogen sulfide is produced and the corresponding hydrocarbon released. Hydrogen sulfide is then absorbed in suitable absorbent and recovered as sulfur in sulfur recovery unit. So this is about sulfur compound. About nitrogen, organic nitrogen compound occur in crude oil either in simple hydrocyclic form as in pyridine C5H5 and pyrrole C4H5, or in complex structure as porphyrin. The nitrogen content in most crude oil is very low and does not exceed 0.1% weight percent. In some heavy crude, however, the nitrogen content may reach up to 0.9 weight percent. Nitrogen compounds are more thermally stable than sulfur compound and accordingly are concentrated in heavier petroleum fraction and residue. Light petroleum stream may contain trace amount of nitrogen compound, which should be removed because they poison many processing catalysts, especially cracking catalysts, zeolite. During hydrotreatment of petroleum fraction, nitrogen compound are denitrogenated to ammonia and the corresponding hydrocarbon. For example, pyridine is denitrogenated to ammonia and pentane. So this is basic nitrogen compound and non-basic nitrogen compound. So the basic like pyridine, quinine, isoquinine, acid acridine, the non like pyrrole, indole, carbazole, benzene carbazole. This is about nitrogen. And nitrogen also by hydrotreating in the presence of catalyst convert to NH3 ammonia and corresponding hydrocarbon. What means by porphyrin? Porphyrin are non-basic nitrogen compound. Non-basic nitrogen compound. The porphyrin ring system is composed of 4 pyrrole rings joined by double bond CH group. The entire ring system is aromatic. Many metal ions can replace the pyrrole hydrogen and form chelate. The chelate is planar around the metal ion and resonance result in 4 equivalent bonds from the nitrogen atom to the metal. Almost all crude oil and bitumen contain detectable amount of vanadium and nickel porphyrin. The following show, see this is the porphyrin structure. So this metal like here iron is replaced the hydrogen and count this structure of porphyrin. Now about oxygen compound. Oxygen compound in crude oil are more complex than the sulfur type. However, their presence in petroleum stream is not poisonous to processing catalysts, but also make corrosion. Many of the oxygen compounds found in crude oil are weakly acidic. They are carboxylic acid, crylic acid, and phenol and naphthenic acid. Naphthenic acid always either cyclopentane or cyclohexane derivative. But this is have the value, commercial value and or importance, and can be extracted by using dilute caustic solution. Total acid content most crude is generally low, but may reach as much as 33% as in some crude. Non-acidic oxygen compounds such as ester, ketone, and amide are less abundant than acidic compound, and they have no commercial value. See, this is carboxylic acid, aliphatic carbon, carboxylic acid. Here cyclohexane, also carboxylic acid. Here aromatic acid. Here phenol, OH ring and OH, whole crystallic acid, and this is also ester, ketone, amide. All these is oxygen compound. Also, there is metallic compound. Metallic compound, many metals occur in the crude oil. Some of these more abundant are sodium, calcium, magnesium, aluminium, iron, vanadium, and nickel. They are present either in organic salts such as sodium and magnesium chloride, or in the form of organometallic compounds such as those of nickel and vanadium, as porphyrin ring. Calcium and magnesium can form salt or soap with carboxylic acid. These compounds act as emulsifier, and their presence is undesirable. Although metal in crude oil are found in trace amount, their presence is harmful and should be removed. When crude oil is processed, sodium and magnesium chloride produce hydrochloric acid, which is very corrosive. Desalting crude oil is a necessary step to reduce this salt. Vanadium and nickel are poisonous to many catalysts and should be reduced to very low level. Most of the vanadium and nickel compounds are concentrated in the heavy residue. Solvent extraction process are used to reduce the concentration of heavy metal in petroleum residue. Thank you for your listening, and we'll see you in other topic, inshallah. Thank you.